Good morning, students. In the previous lecture, we discussed about the radius of gyration, its dependence, and the physical significance of the radius of gyration. In this lecture, we are going to derive a formula for the moment of inertia of a uniform disk. What is this? Disk is an object which is circular in shape and its mass is uniform everywhere. It is called as a disk. We all are familiar with it. Okay, now for considering or for determining the moment of inertia of a disk, consider a disk here having mass capital M and the radius of this ring is equal to capital R. Here we introduce a new term called as surface density. What is surface density? Surface density sigma is equal to, it is mass per unit area. Therefore, in this case, we can write surface density sigma is equal to mass, that is capital M, and area. What is the area of this circular disc? It is equal to pi r square. Okay, give it as equation number 1. Now, to determine the formula of moment of inertia of a disk, consider that this disk is divided into a number of disks and having each disk of thickness dr and each disk of mass m. Consider such one disk, an elemental disk we consider here of thickness dr and the mass of this ring is equal to dm. Now, if the thickness of this ring is equal to dr and the mass is equal to dm, then we can easily calculate the area of this elemental ring. What is the area of this elemental ring? The area of this elemental ring is equal to, we know the formula for area is equal to length multiplied by breadth. Therefore, this area is equal to, what is the length? Length means the circumference of this circular ring, which is nothing but it is equal to 2 pi r. And what is the thickness? The thickness of that ring is equal to dr. Therefore, we can write the area of this elemental ring A is equal to 2 pi r multiplied by dr. Similarly, as we calculate the surface density in the case of whole disk, now we are going to calculate the surface density of this elemental ring. What is sigma? Sigma is equal to mass divided by area. And what is the mass? Mass is equal to dm. And what is the area? This area is equal to 2 pi r dr. Okay. Therefore, from this relation, we can say that this dm is equal to 2 pi r sigma dr. Okay. This is equation number 2. Now, if we have to calculate the moment of inertia, we know the formula for calculating moment of inertia. What is the formula? If this disk is uniform, they use integration. Therefore, what is the moment of inertia? This I is equal to, what is I is equal to? It is equal to the mass multiplied by the square of the distance from the axis of rotation. Here, this elemental ring having mass dm and its distance from the axis of rotation is equal to small r. Therefore, the moment of inertia of this elemental ring about this axis of rotation is equal to dm multiplied by r square. Now, this moment of inertia is only for this elemental ring. If we have to calculate the moment of inertia of this whole disk about this axis of rotation, then we must integrate this equation within the limit What is the limit? Within the limit 0 to r. It means the minimum radius of this disk can be 0 and the maximum is equal to r. Therefore, if we have to calculate the moment of inertia of the whole disk, then we should integrate this within the limit 0 to r dm multiplied by r square. Now, if we keep the equations, this relation in this equation, we get this 0 to r dm. What is dm? It is equal to 2 pi r sigma into dr, and it is multiplied by r square. Now this r and r get r cube, and this term 2 pi sigma, it is in the out of the integration sign. Therefore 0 to r, it is r cube dr. Now in 11th standard we learn about this simple integration, and the answer of this integration is equal to r to the power 4 divided by 4, and the limit for this equation is from 0 to r. Okay, it is 2 pi sigma. Now keep this capital R replaces this small r, we can write here this is r to the power 4 divided by 4. Now we can keep here the value of sigma. This sigma is equal to, it is sigma is equal to m upon pi r square. Though 2 pi into, what is it? It is m upon pi r square, and it is multiplied by r to the power 4 divided by 4. By simplifying this equation, we get the moment of inertia of the disk about this axis is equal to m r square divided by 2. So the moment of inertia of the disk about an axis which is perpendicular to the plane of the disk and passing through its center is equal to 1 by 2 mr square, or it is simply equal to mr square by 2. In this section, we discuss about this moment of inertia of the disk. In the next section, we are going to discuss about the theorems, important theorem, parallel axis theorem and perpendicular axis theorem. Now, we are going to stop here. Thank you. Have a good day.